Okay, today is uh, 2nd of November 2020, and we are discussing about NLP problems, nonlinear programming problems. We call a problem nonlinear that it has several conditions. In linear programming problem, we have seen there is an objective function and there may be some constraint, and under some constraint we have to optimize a objective function. That was the job in linear programming problems. But in nonlinear programming problem, there are three types of cases. First type, the objective function is in the nonlinear form and all the constraints are in the linear form. Then it will be called a nonlinear programming problem. Okay, the objective is nonlinear and the constraints are linear. Now, the second case, if the objective function is in linear form and anyone or some or all the constraints are in the nonlinear form, then the problem is a nonlinear programming problem. If the objective function is in the nonlinear form and anyone or some or all the constraints are in the nonlinear form, then the problem is a nonlinear programming problem. So the point is, in our problem there is two type of functions. One is objective function, second one is constraint function. Now if any one of these or all of these are in nonlinear form, then it will be a nonlinear programming problem. So there is a chance that the objective function is nonlinear and the constraints are linear. There might be a chance that the the objective function is linear and the constraints are nonlinear, and there is a chance that the both of the constraints and the objective function all are nonlinear. So if any one of these two type of functions are nonlinear, or if everything is nonlinear, then it will be called a nonlinear programming problem. So when we call it nonlinear, when the function fx varies with higher orders of x. How much higher? If the order of the x is greater than 1, then it will be a nonlinear function, like y equal to x square, y equal to x cube, y equal to x to the power 4, y equal to x square plus x plus 1. So all these cases, y or fx is varying with higher order terms of x. The order is greater than 1. It might be from 2 to infinity, the order of the x. So if the order of the x is higher than 1, so y is varying or fx is varying with x square or x cube or x3 or x to the power 4 or x to the power 5 or x to the power n, then it will be called a nonlinear programming problem. Okay, what is nonlinear programming problem? Is it clear?
Sir.
Okay, now now if we draw a curve of an objective function in some region, okay, just between 2 points, and I have drawn an arbitrary curve here. This is an arbitrary curve. So if we look at this figure, these downward arrows are on some points which are called as extreme points. So what will be called extreme points? The points which are highest or lowest with compared to the points beside it, then they will be called extreme points. So all these points are arrowed, both upward arrow and downward arrow, both are those points which are literally higher compared to the point beside it or lower than the point beside it. So these points are called extreme points. Extreme points are comprises of the maximum points and the minimum points. These maximum points are called maximas and the minimum points are called minimas. Okay, now these maximum points are called maximas, and in this whole region, in this curve, in this drawn curve, what we can see, there are 5 down arrows which are representing the maximas. These will be called local maximas. So in local maximas, there will be one highest, most highest point, this the denoted with the max. So this point is called the global maxima, while the others are called local maxima. So the maximum, all maximums are called global maximums or global maxima. Similarly, this point, here is the minimum of all the minimums. So this is why this point is called global minima. So this is global minima, this is global maxima, and all these points are local maxima. These points are called local minimas. So these global maxima and global minima and local maxima, local minima, is these things are clear?
Yes, sir.
Okay. Now the concept of extreme points is also clear then. Extreme points means either it will be a maxima or it will be minima. It might be a local, it might be a global. That we need to test. Now, these types of nonlinear programming problems are two types: unconstrained and constrained. So that means the nonlinear programming problems will have an objective function which we have to optimize, but in two cases: without, case 1 without any constraint, case 2 with constraint. So let us discuss with unconstrained nonlinear programming problems. This unconstrained, let us start, write it up. Unconstrained nonlinear programming problems. There are three types of problems. Option 1 is a single variable. Option 2 two variable, and option 3 is multivariable. Okay, now in single variable optimization problem we will discuss the first. Let us start with single variable optimization problem. What we do here, we have the objective function. In that objective function there is only one variable, and the necessary condition, so let us write it out. Objective function have only one variable, and the necessary condition for this case is dfx dx is 0. Okay, so if we do not find dfx dx 0 at any of the points, then that problem will not have any extreme points, so it will denote as a straight line. If we find dfx dx equal to 0, that means it will have one, or probably just maybe, not probably, maybe more than one number of extreme points. So the point is, if we do not find any extreme point, we cannot find any maxima or minima, because the extreme points are either maxima or minima. Now if we do not find an extreme point, then of course we cannot find any maximas or minimas. So the necessary condition is this dfx dx should be equal to 0. This is the necessary condition, and that value for which this dfx dx is 0 is called x0, and that will be called extreme point. So if at x equal to x0 dfx dx is equal to 0, that implies x0 is an extreme point. Okay, now we need sufficient condition to find out, to determine whether this extreme point is a maximum point or a minimum point. Okay, so sufficient condition is required to find out whether this extreme point we can find by doing this, that point, that extreme point is either a maxima or a minima. So how can we do that? The sufficient condition we have to find out is double derivative the function with respect to x. Now if this less than equal to 0, then the function fx will be concave. Then the function will be concave and will give us a maximum value, will be a maxima at x equal to x0. Okay, now if this d2 of fx dx2 this greater than equal to 0, then function fx will be convex and x equal to x0 will be a minimum. Okay, so is the case clear? If there is a single variable, only fx is depending on x, so in that case it will be single variable problem where the objective function is fx, and the sufficient conditions, the necessary condition is dfx dx should be equal to 0, and the necessary conditions are this d2 fx dx2 less than equal to 0, then it will be a concave, or the function will have a maximum value at x equal to x0. And if this d2 fx dx2 is greater than equal to 0, then the function will be convex and will give you a minimum.
Hello,
হ্যাঁ
sir.
হুম হুম বলো
Sir, dfx by dx equal to 0. So that means sir function is a constant. It's not variable, sir.
yes, that's why you cannot find any extreme point. That's the problem. So if it is 0, that means at a particular value of x,
Yes, sir.
it gives you end point, extreme point. So if you look at these points here, what is dfx dx? Dfx dx are basically the slope. So at this function, these points, these topmost and bottommost points will have a zero slope. That means if we draw any tangent on those points, it will be horizontal. So that's why with this we can find out which points are extreme points. So what you need to do is to find out if the problem is a non-linear programming problem with a single variable optimization problem and unconstrained one. Then what you have to do, you have to just derivative once with the variable with respect to the variable. So if fx is depending on x, you just do one time of derivative and equate it with equal to 0 and find out the x value. When you find out the x value, that is x0, if you find out that that is the extreme point, now you check for whether the extreme point is either maxima or minima. So you double derivative the fx with respect to x and find out whether it is greater than 0 or less than 0. If it is greater than 0, that means you will get a minimum a minima, or if it is less than 0, then you will get a maxima. So let us solve it with a problem. It will be more easier. The problem is to find out if the following function is concave or convex. Okay, so a function is given. A function is given which is fx is equal to x1 to the power 4 plus 2x1 square minus 5x1. If you look at the objective function, you have to determine the function is concave or convex. Okay, this is a very easy function and you have to find out whether it is concave or convex, or find out the maxima or minima. Okay, so basically this are same problem. I have written two different statement for the same equation. So basically both are same. Now you just write down the function here, fx equal to x1 to the power 4 plus 2x1 square minus 5x1. You can see that this problem is a nonlinear problem, as the objective function depending on x1 to the power 4 x1 square, that means these are the higher order terms, thus it will be of more no higher terms, and that's why they are nonlinear programming problem. Now you have to find out whether there is an extreme point or not. If there is an extreme point, then is it maxima or is it minima? So let us check it out. We have to go for first the necessary condition. So we will write applying necessary condition. What is the necessary condition? dfx dx will be equal to 0. So let us check it out. dfx dx means here 4 x1 cube plus 4 x1 minus 5, and we are equating it with 0. That will give you a particular uh, extreme point. So let us stop here because we have to check whether it is concave or convex. Yes, কেউ কিছু একটা বলছিলে।
স্যার dx1 হবে না স্যার?
হ্যাঁ হ্যাঁ, কি বলছো?
স্যার dfx by dx1 হবে না?
dfx
dx1
dx1 হবে, right right. This is the variable is x1. Thank you very much, you got a right point, my mistake. So now from this we can find out, from this equation we can find out x1. So we can get a value of x1 here. Okay, right now this is not required, but if we want to find out maxima or minima, then we need the x1. Okay, so let us first find out whether this is concave or convex. So now for that we apply the sufficient condition. If we apply the sufficient condition, then what we have to do is to find out double derivative of fx with respect to x1. Then what we can get is 12 x1 square plus 4. So of course this is depending on the x1 square. So under any value of x1, this due to fx dx1 2, this term will be greater than 0. So that's why we have found this term, this sufficient condition implies that this is a convex function as we have discussed, and it will be a minimum. So now if we find out this x1 and this value, if we put into this equation, x1 to the power 4 plus 2x1 square minus 5x1, then we will get the optimized value or minimum value of objective function fx equal to this. You just push the value of x and you will get the minimum fx. So now can you tell me what is the value of x1 from this equation? Anyone? It will take time to solve it, so you just have the idea. what we have to do is to find out x from this equation, put this value of x in this objective function, and you will get the optimized or the minimum value of this function. And the point at x1 equal to that particular point, this point will be extreme point, and that will be a minimum. So is the operations clear? We can do it with another example, easy example. The same statement with fx equal to 3x to the power 5 minus 5x cube. So now let us apply the necessary condition. The fx dx is equal to, from this equation we can get 15x to the power 4 minus 15x square, and we equate it with 0. So in this will give you 15x square x minus 1 into x plus 1 is equal to 0. So from here we can find that x might be 0, 1 and minus 1. Okay, we get three values of x. So we'll get three different extreme points. Now we apply the sufficient condition. Sufficient condition says the double derivative of fx with respect to x will give you 15 into 4x cube minus 2x. Okay, so at x equal to 0, look carefully. At x equal to 0, the double derivative is 0. So this is a point of inflection. So at x equal to 0 is a point of inflection. Okay, now let's go to x equal to 1. Let us see what happens. Put the value and you will get 30. So it is greater than 0. So at x equal to 1, it is a minima, and at x equal to minus 1, the double derivative is equal to minus 30, which is less than 0, and so that means at x equals to 1, it is a maxima. Now if you put x equal to 1 at this value, then you will get the maximum of fx. If you put x equal to 1, you will get the minimum. If you get x equal to minus 1, then you will get the maximum value. So max fx can be found by putting x equal to minus 1. So it will be minus 3 plus 5, 2, and the minimum fx will be putting x equal to 1. X equal to 1, it will be 3 minus 5, so it will be minus 2. So this is the minimum value of fx, this is the maximum value of fx. Okay, so with this problem we will stop today.
স্যার আগের অঙ্কটা স্যার x1 এর ভ্যালু বের হলো স্যার 0.778
0.778. So x1 is 0.778. Now if you put the
স্যার
value,
আরেকটা আছে স্যার
বলো,
স্যার ওর তো তিনটা ভ্যালু স্যার, আরেকটা আছে মাইনাস
minus
0.389
389, আরেকটা
হ্যাঁ After same sir, minus 0.389.
Okay, then that means there are two
Nothing wrong
values.
with everything.
There are two
Hmm.
values. Now you put these two values in this equation. Okay, you put
Okay.
first 0.778. Whatever you put, you will get the value greater than 0. So now if we put the values over here, you will get the maximum value of the function.
Okay, sir. Okay, sir.
Just like this, here we have got three different values. We have checked for all these three values, putting these values on this equation, and putting these values, we have found out that in first case we got 0, this point of inflection. When greater than 0 it is minima, when less than 0 it is maxima. So the putting these values over here, putting this value over here, we have got the minimum point. Putting this value over here, we have got maximum point. So this is how you can find out the values of the function, maximum and minimum values of the function. Later on we will discuss on more examples, and I hope will be able to understand in a more better way. Okay.